And now, ladies and gentlemen, we're proud to present the grand prize winners in this year's competition. These are the components that, as voted by this year's judges, have achieved the highest level to which PM part design can aspire. The grand prize in the automotive transmission category has been awarded to GKN Sinter Metals for a planetary carrier assembly made for Ford Motor Company. The sinter brazed copper steel assembly, comprised of a cage and a flanged hub, goes into the all-new 10-speed transmission for the Ford F-150 pickup. The cage component, which with its full-form external spline has a 35 square inch surface area as well as an extremely thin profile, required utilization of all 4 platens of a 1,500-ton CNC press to support the pressing area. The flanged hub component incorporates a novel PM design geometry to net form the locking lugs on the end of the hub that create a twist lock type bearing retainer, which requires only a simple turning motion to fix its functionality. The pinion window lube paths, lock splines, and swage assembly features are net formed, thus minimizing machining stock, component mass, and cost. The finished carrier assembly requires only simple turning operations to hold the tight tolerances on the bearing bores, pinion pin shaft holes, and thrust faces. In close collaboration with the customer, the fabricator designed and refined the twist lock concept, reducing by 50% the stresses that FEA analysis had predicted for the original castellated design. The grand prize in the automotive engine category goes to Phillips Metasize Company for a 4-slot fuel valve seat made for Delphi. The metal injection molded part goes into the Multec 3.5 compressed natural gas, or CNG, fuel injector that satisfies the market's need for a low-cost, low-pressure port fuel injector. It is currently used by several small engine and automotive applications, including aftermarket CNG conversions for trucks and cars, helping contribute to a reduction in greenhouse gas emissions. The part is fabricated from 17.4 pH stainless steel, a necessity in automotive applications with stringent requirements for corrosion resistance and wear durability. MIM technology was chosen for its ability to design a complex seat that could be net-shape fabricated, thus eliminating expensive machining operations. The intricate lip edge features of the slots are critical for proper performance of the rubber valve seal that rides on them. An electropolishing operation ensures a smooth, uniform surface of this lip seal. Centerless grinding of the OD to a tolerance of plus or minus 0.0002 inch is the only other secondary performed. The grand prize in the automotive chassis category has been won by GKN Sinter Metals for a copper steel output pulley made for Nidec Automotive Motor Americas. The part goes into an electric reclining mechanism in a minivan rear seat application. The part offers a lot of functionality in the small footprint mechanism. The groove for cable retention, the cam for radial movement, and stops at both ends. Designing the pulley as a net-shaped component, which includes an undercut radial groove, entailed the development of what the fabricator calls extreme forming, a proprietary tooling concept requiring 4 levels controlled by CNC logic. Net forming the groove eliminated the time-consuming milling operation that would have otherwise been required with a machined steel part, and which would have increased its cost by about 50%. Designing the part for fabrication at a density of 6.3 grams per cubic centimeter resulted in a 20% weight savings over a fully dense machined part. The pulley is produced at an annual quantity of 500,000 units. The grand prize in the aerospace military category has been won by Dynacast Portland for a MIM 17.4 pH canard made for UTC Aerospace Systems and Raytheon Company. The stainless steel part is used on the Talon, an add-on guidance and control package that transforms a legacy 2.75-inch Hydra 70 unguided rocket into a low-cost, precision-guided weapon. 3 canards on each Talon act as the primary flight control surfaces. While the injection molding tooling was fairly straightforward, Sintering demanded specially engineered and fabricated ceramic setters in order to maintain the extremely accurate profile tolerances of the airfoil surfaces without secondary operations, which is very difficult to achieve during shrinkage from green to sintered component. Machining the attachment pivot lug detail on the proximal end and at the latching notch on the distal end are the secondary operations performed, followed by solution treatment and aging, and finally bead blasting. The conversion of the canard from one fully machined from rod to the MIM design at a cost savings of more than 65% represents a successful collaboration to qualify a highly critical structural application by two major aerospace organizations. Several milestones had to be achieved during this qualification process, especially the fundamental testing and analysis of the stress corrosion properties of the MIM material, which involved the integral use of 3D CT scanning during development. The grand prize in the hand tools recreation category goes to FMS Corporation for a 30-tooth drive sprocket fabricated from sinter-hardened steel with a proprietary machining additive made for Polaris Industries Incorporated. The part goes into a motorcycle where it is driven by the output shaft of the transmission and, in turn, drives the rear wheel via a toothed pulley. The high-mass component has 6 levels, achieved through both multiple punches and face forms. The 30 proprietary sprocket teeth on the outer profile and 33 involute spline teeth are formed in a single press stroke, as well as the 10 weight-reducing holes and the 2 smaller holes that are subsequently tapped. Other than the tapping operation, the part is formed completely net shape, which offered cost savings over the previously machined part. The sinter hardening alloy used, combined with a machinability additive, enabled the component to possess heat-treated properties with very consistent dimensional control and the ability to machine the tapped threads in the heat-treated condition. The grand prize in the hardware appliance category has been awarded to Indo-MIM Private Limited for 3 MIM parts: upper stop ring, and stop sleeve, made for Grohe, Germany. The parts go into the valve of a bath shower temperature controller unit. Made of MIM 316L stainless steel, all 3 complex parts are fabricated close to net shape, and special ceramic setters are employed for enhanced shape retention during sintering. The parts only need a final tweaking with a coining fixture to adjust a small distortion. The stop ring and stop sleeve are a conversion from previous plastic versions, which exhibited strength issues. The increased strength of the MIM parts and consequent reduction in the number of rejects translates to savings estimated at 15%. Annual volume of the stop ring and stop sleeve is 60,000 units, while 1.2 million of the upper stop ring are made annually. The grand prize in the medical dental category goes to ARC Group Worldwide for a MIM surgical keel punch made for Paragon Medical. The part functions as a broach to remove bone during knee surgery. Made from MIM 17.4 pH stainless steel, the part is complex for metal injection molding due to large variations in wall thickness, as well as the many long, thin teeth along its perimeter. Additionally, mounting features to attach the component to mating parts are molded in place, as are clips that hold a size identifier. The part is molded and sintered to net shape with no additional coining, machining, or other post-processing to alter its shape. Tight tolerances are maintained using unique engineered sintering fixtures. The part was designed for metal injection molding, as it would be cost-prohibitive to machine at the required volumes. The grand prize in the Industrial Motors, Controls and Hydraulics category has been won by FMS Corporation for a stainless steel fitting. The fitting provides a latching mechanism to easily move a safety pin on a hydraulic lever up and out of the way. An innovative ramp design acts as a cam surface to move the pin from one position to the other. The complex 5-level part also incorporates a hex-shaped OD, an ID keyway, and a counterbore, which are all fabricated net shape. Machining an OD thread and a step in the counterbore are the only secondary operations performed. Investment casting and machining, the only other possible processes for manufacturing this component, could not compete with PM from a cost standpoint. And since this component required both strength and corrosion resistance, 316L stainless was the only acceptable material choice. Ladies and gentlemen, these are the winners of grand prizes in the 2017 PM Design Excellence Awards competition. Please join us in saluting their achievements as we invite company representatives to come up to the stage to accept their awards.